Welcome to the 2026 Digital Economy Stack. We will explore how intelligence, silicon sovereignty, and baseload power are converging to form a unified industrial matrix. The infrastructure stack has three layers. Layer 1 is intelligence, the application layer, which is unconstrained. Layer 2 is silicon, the compute layer, a physical choke point. Layer 3 is power, the foundational layer, the ultimate planetary constraint. The AI frontier map shows that open-weight models are achieving parity in software engineering. The premium is shifting towards specialized autonomy, with key players positioned across open and closed source domains. We are in the post-prompting era, with the agentic loop architecture. Large language models are functioning as persistent, always-on infrastructure in a cycle of heartbeat, assess, act, and resolve and log. The self-evolving codebase illustrates how software capability compounds autonomously. The intelligence layer is unconstrained by human development cycles, shown through the Glasswing and Minimax architectures. The compute layer escalation shows hardware becoming the new commodity. The AI build-out phase is transitioning to core industrial infrastructure, projected to reach $2.52 trillion annually by 2026. Driven by massive Big Five CapEx and TSMC's growth. The TSMC gravity well defines the Angstrom era. Unmatched yield and reliability are forcing tech giants like Apple, NVIDIA, AMD, and Broadcom to single-source their critical components from Taipei. The Silicon Sovereign Matrix highlights NVIDIA's dominance, maintaining over 75% market share in the accelerator market. Their high gross margins fund an R&D pipeline that competitors struggle to match. The unit economics waterfall demonstrates the massive hardware margins, often reserved for enterprise SaaS, achieved through software lock-in and supply scarcity. The NVIDIA H100 for example, achieves an 88.1% gross margin. The advanced packaging choke point reveals that the ceiling on AI scalability is the physical limitation of advanced packaging output, specifically TSMC's CoWoS capacity constraint, allocating 60% to NVIDIA. The energy demand bridge shows that AI infrastructure requires clean, firm, 24/7 baseload power. Intermittent renewables cannot physically bridge the unbridgeable baseload deficit created by unyielding AI data center loads. The Global Power Map highlights U.S. initiatives. Early mover states are building foundational baseload infrastructure to attract the next wave of AI data centers, primarily through nuclear and geothermal projects. The regulatory friction matrix illustrates that bureaucratic layers have choked deployment despite available capital. Only 12% of appropriated energy innovation funds have resulted in actual outlays or steel in the ground. The 2026 bottleneck hierarchy shows that AI scalability is fundamentally an energy problem. Software is limited by silicon packaging, and silicon is bottlenecked by grid power, with power being the ultimate constraint. The physical layer wins. The 2026 digital economy is defined by the paradox that advanced AI is tethered to the physical world. Ultimate winners control the foundries, supply chains, and baseload power grids.